Good morning to all of you. So in our previous class we have seen about the image formation by the help of concave lens. We have also seen the sign convention of spherical lens, and we have seen the lens formula and magnification produced by spherical lens. Now today we will see about the power of a lens. What do I mean by power of a lens? Simply, when we are talking about the power of a lens, we say that the power of a lens is reciprocal of its focal length. Power of a lens is reciprocal of its focal length. And focal length P is, the formula is P is equal to 1 upon F, where F is in meter. And the SI unit of power is diopter. Okay, so basically many times in your board exam a question has asked what do you mean by 1 diopter. Okay, so 1 diopter is the power of the lens if it is P is equal to 1 upon F. So if we make F is equal to 1, so P will also equal to 1. What will be P? P will be equal to 1. This is 1. Okay, so P is equal to 1 upon F. If we will make focal length as F 1 meter, then power will be how much? 1 diopter. So 1 diopter is the power of a lens whose focal length is 1 meter. So what is 1 diopter? It is the power of a lens whose focal length is 1 meter. Now we all know that, and in the case of convex lens focal length is positive, and in the case of concave lens focal length is negative. We have seen in the sign convention. So if suppose the power of the lens is positive, the power of the lens is positive, then it is convex lens. It is which lens? Convex lens. Suppose in your home some person is using specs who is having the power in positive, means in the specs the lens which is used is convex lens, because if focal length is positive it is convex lens, and if focal length is negative, then it is concave lens. And this about the convex lens and about the concave lens, about the use of power, we will study in our next chapter also, human eye and colorful world, in which we will see the defects of vision, as I have already explained you in your 8th class. Okay, that there are the defects of vision like myopia, hypermetropia, presbyopia, astigmatism, cataract, that we will once again study in the next chapter, that is human eye and colorful world. And this chapter, reflection and refraction and human eye and colorful world, these two chapters are in the board. From these two chapters 12 marks question needs to come. So if sometimes the question is asked, maybe asked in the exam, that power is given to you, that let us we can say that power is equal to -3 diopter, and it has asked that which type of lens is used. So while seeing the power, if the focal length will be negative, then power will also be negative. If the focal length will be positive, then power will also be positive. So if it is -3 diopter, it means that in case of that, the power of the lens which is used is our concave lens. Obviously it will be concave lens because the power is negative. And now if it is asked to calculate the focal length, so what we will do? P is equal to 1 upon F. P is given as -3, so F is equal to -1 upon 3, that is minus 0.33 meter. Our focal length will be -33 centimeter. So very much simple question used to ask sometime for 1 marks in your board exam. Okay, now we will see two small topics which I have left before. One is luminous and non-luminous object. As you all know, what do we mean by luminous objects? Which emits light of their own. Which emits light of their own. That object is said to be luminous object. Okay, and what is non-luminous object? Non-luminous object do not give out light of their own. Do not give light of their own. So the object, basically, whether they have their own light or they are dependent on other, in that we classify the object into two categories. One is luminous and other is non-luminous object. Luminous objects emit light of their own, like sun, star, lamp, fires, fireflies, and glowworms. And non-luminous objects do not give out light of their own, like moon, trees, hands, earth. Okay, so as we know that the moon, we are able to observe the moon because the light from the sun fall on the moon, and after reflection it come to the earth's surface and it enters in our eye, and due to which the moon is visible to us. Now reflection, when we have deal with the reflection are of two types, regular and diffuse reflection, or we can say regular or irregular reflection. Regular reflection is also known as specular reflection, and irregular reflection is also known as diffuse reflection. Okay, so here, as this topic was taught to you in your 8th class also, when all the reflected ray from a given smooth surface, this is a smooth surface, and all the reflected ray from a given smooth surface are parallel for parallel incident ray. Means if the incident ray are parallel, then the reflected ray and the reflected ray are also parallel, so the reflection is known as regular reflection. And if for a given set of incident parallel, means here the incident ray is parallel but the reflected ray do not remain parallel to each other. Here in the case of smooth reflection, or you can say regular reflection, the plane it takes from the plane surface, and in case of what is happen, if this incident ray are parallel to each other, so after reflection all the reflected ray will also be parallel to each other. All the reflected ray will also be parallel to each other. But here what is happening, if the surface is not smooth, though the incident ray are parallel to each other, you are seeing here all the incident ray are parallel to each other, but the reflected ray are not parallel to each other. So when all the reflected ray for a given smooth surface are parallel for parallel incident ray, the reflection is said to be regular reflection. And when for a given set of incident parallel rays, the reflected ray do not remain parallel to each other, means incident ray is parallel but the reflected ray are not parallel to each other, the reflection is said to be diffuse or irregular reflection. And it when we are talking about this, okay, so in the case of regular reflection takes place from a smooth surface like mirror, silver spoon, etc. And it occurs, irregular reflection occurs from which surface? Diffuse surface, means rough surface like wood, table, door, book, etc. But please note one thing in mind, that whether it is regular reflection or whether it is irregular reflection, whether it is specular reflection or whether it is diffuse reflection, law of reflection is obeyed in both the case. Law of reflection is obeyed in both the case. Okay, now I have solved some lens problem for you, and after that I have given some questions, many questions to you for your solving purpose. So what you have to do, the question which I have given you as homework, please solve that question properly, and after solving that, send it on my WhatsApp. send it the solved problem on my WhatsApp. Okay, it's compulsory for all of you, for all the student of 10th C. It is compulsory that after solving the numerical which I am giving to you, or after making the notes, you have to send the pic on my WhatsApp number. So here the first problem for you is a concave lens have focal length 15 centimeter. At what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens? Also find the magnification produced by the lens. So here focal length f, since concave, it is concave lens, focal length will be negative. And at what is asked, at what distance u is asked, and it is given from the lens be placed so that it forms an image at 10 centimeter from the lens. Okay, so here the focal length is given to you. That focal length is how much? 15 centimeter. So since it is concave lens, it will be minus 15 centimeter. At what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens? Find the magnification produced by the lens. Find the magnification produced by the lens. Okay, at what distance should the object from the lens be placed so that it forms an image at 10 centimeter from the lens? So we are getting V is equal to image distance, V is equal to minus 10. Okay, so here we have got that V is equal to minus 10. So now what it has been asked, object distance has been asked. Okay, so by the lens formula we know that 1 by f is equal to 1 by v minus 1 by u, or 1 by u is equal to 1 by v minus 1 by f. So put here minus 1 by 10 plus 1 by 15, that is minus 1 by 30. So u is equal to minus 30 centimeter. Where the u is placed? U is placed as minus 30 centimeter. Object is placed at how much distance? Minus 30 centimeter. So if the object is placed as minus 30 centimeter and the focal length of the our concave lens is 15 centimeter, since you all know that concave lens always give virtual and erect image. Concave lens always give which type of image? Virtual and erect image, because it is a diverging lens. So that's why I have written V is equal to minus 10 centimeter. Please don't be confused that why V is equal to minus 10 centimeter, why not V is equal to plus 10 centimeter. This confusion always arises in the mind. Why we have taken as minus 10 centimeter, why we are not taking V as plus 10 centimeter. So first read the question properly, that here it is given concave lens, and concave lens is a diverging lens. So if concave lens is there, obvious the image will be virtual and erect in all the cases. So that's why means image is same size as the object, and if anything which is on the left of the optical center, it is considered as negative. So what is V? V is equal to minus 10 centimeter. Object distance has been asked, so we have find that u is equal to how much? Minus 30 centimeter. And what is the magnification? We know magnification m is equal to V upon u, and V is how? Minus how much? Minus 10, and u is how? Minus 30, that is 1 by 3, that 0.33. It means that the magnification is less than 1. Since magnification is positive, 0.33 means magnification m is equal to plus 0.33. It's positive, that is virtual and erect, and since it is less than 1, that's why the what will be the image will be smaller than the object. Image will be smaller than the object. Okay. Now this was about sometime in this what has been asked in the exam. Draw the ray diagram also. So what you will take? You will take a concave lens and you will take a focal length of that concave lens as 15 centimeter. So if f1 will be 15 centimeter, f2 will be 15 centimeter. So 2f1 will be 30 centimeter and 2f2 will be also 30 centimeter. Object distance you have calculated. Place the object as minus 30 centimeter and draw the ray diagram. And what will be the ray diagram? When the object will be placed anywhere between optical center and infinity. But if it has asked after the question to draw the ray diagram, so you have to do proper scaling of it. If it is 15 centimeter is very large distance, so you can scale it. Let 5 centimeter or let 10 centimeter is equal to 1 centimeter. Okay, you can scale it and after that you can solve it. Now second question. A 2 centimeter tall object is placed perpendicular to the principal axis of a convex lens. Of a convex lens of focal length 10 centimeter. The distance of the object from the lens is 15 centimeter. See, by seeing the question itself, you can get the nature of the object. Okay, now find the nature, position and size of the image. Also find the magnification. So here see, 2 centimeter tall object means height of the object is given 2 centimeter. Since it is convex lens, so focal length will be positive, so f will be 10 centimeter. Now the distance of the object, distance is always negative, so u is minus 15 centimeter. So we are seeing here one thing, f is 10 centimeter and u is 15 centimeter. If f is 10 centimeter, then 2f will be 20 centimeter. Mean by seeing this also we can say that object is placed between f and 2f. And if the object is placed between f and 2f, so we will get the image beyond 2f, and it will be our, we can say that real and inverted, and it is magnified. So this is according to case, but here we cannot write like this, because here it is numerical is given, here some value is given, so you have to solve the numerical and find the exact value. So HO as given that is very much important. Please, given that, after given that you have to write the formula which is going to be used, and after writing the formula which is going to be used, what you have to do, then you have to do the process, and don't forget to write the unit. So HO is given 2 centimeter, F 10 centimeter, U minus 15 centimeter. V has been asked, and since HO is given, so you have to find HI means height of the image. This has been asked. We know that from lens formula, 1 by V minus 1 by U is equal to 1 by F, or 1 by V is equal to 1 by F plus 1 by U. So 1 by V is equal to 1 by 10. And this is plus, but here U is minus, so minus 1 by 15, LCM is 30, so it will be 3 minus 2, that is 1 by V is equal to 1 by 30, or V is equal to 30 centimeter. So now we have got that V is 30 centimeter, that V is positive, and we all know that if V is positive in the case of lens, then the image is formed. If V is positive, then the image is formed on the right side of the lens. Okay, so if the image is forming on the right side of the lens, it is real and inverted. That's why it is real and inverted. Now what we have to find? Magnification. So we know M is equal to HI by HO. Somewhere we can write HE by HO also. Then don't be in confusion. Somewhere it is written H1 as H2 as, okay, or H2 H1. So don't be in confusion. Okay, so M is equal to HI by HO, that is equal to V by U. So M HI upon, in place of HO what is given, 2 centimeter, is equal to V is how much given, 30. Okay, U is given minus 15. So minus 15 and 30 they will cancel, then it will become minus 2. So what will happen? HI will be our minus 2 into 2. So HI will be minus 4 centimeter. Means height of the image is size of the image, or height of the image is how much? Minus 4 centimeter. Minus is indicating that the image is inverted. So from here also we can get that from sign which we are getting in the case of our HI. If HI is positive, then it is erect. If HI is negative, then it is inverted. Now what you have to do, you have to solve this numerical. Okay, there are 19 numerical, and basically this all are from your exercise itself. So I have given you for practice purposes that it is very much easy that define the principal focus of a concave mirror. Name a mirror that can give an erect and enlarged image of an object. Why do we prefer convex mirror as a rare view mirror in the rear view mirror in vehicles? Okay, and there are some questions on what on refractive index also. We have already solved this numerical we have already solved. This is also very much easy. We have studied that whenever light move from rarer to denser medium, it moves towards the normal, and whenever light ray move from denser to rarer, it moves away from the normal. In previous slide already I have explained that what do we mean by 1 diopter of power of the lens. Okay, now here a concave lens is given. A concave lens and forms a real and inverted image of a needle at a distance of 50 centimeter from it. So all the things is given to you. So what you have to do, where is the needle placed in front of the convex lens if the image is equal to the size of the object? This was the case when the object is at 2f1, image is formed at 2f2. So here it is given that only a concave lens forms a real and inverted image of a needle at a distance of 50 centimeter from it, where the needle placed in front of the that will be also 50 centimeter. Now from this you have to calculate the focal length, and from the focal length you have to find the power, and we all know P is equal to 1 upon F. Okay, so P is equal to 1 upon F. After finding F, from here you find the F, and because now from this question, reading the question, you will get U and V. So apply the lens formula, or by seeing also you can calculate what is F, and after F find the P. Here power is given, power is asked, and it is concave lens, and we all know that concave lens is having focal length in negative. So F is equal to minus 2 meter, so P is equal to 1 by F, that is P is equal to 1 by minus 2. Solve it. Now here next numerical is an object. See, this type of numerical many time has been asked in your board exam. A object 5 centimeter in length, means HO is given, is held 25 centimeter away from a converging lens. U is given. Okay, focal length is all, converging lens means convex lens. F will be positive, F is also given. Now what you have to do, you have to draw the ray diagram. By using this you draw the ray diagram, and also find the position, size and nature, and compare it by the ray diagram what you are getting exactly. By solving it you are getting the same or not. Here it is concave lens of focal length 15 centimeter forms an image 10 centimeter from the here. See what is given, focal length is given, minus 15 centimeter forms an image, V is given. So it is this problem I think that we have solved earlier, okay, in the example. If not solved it, but here one thing has been added, draw the ray diagram. So you have to do it. The magnification produced by a plane mirror is +1. Plus means virtual and erect, and 1 means same size, 5 centimeter. So all these numericals are very much easy, but these numericals are very much important, because the most important parts of these numericals are the sign convention. If you will write sign convention properly, then your answer will be proper. If in place of minus somewhere you will write plus, then all your problem will be wrong. So plus, please first go from given that, what is given that in the question, write. What has been asked, that also write. After that write the formula which is used, after that procedure, after that answer, and after that ray diagram. And if like this in question, here first you have to draw the ray diagram by taking this, and now by this value you have to find the position, size and nature of the image form, and for your convenience compare that. If both are same, then it is okay, and if both are not same, so somewhere we are doing the mistake. I think that now this chapter, light reflection and refraction, is clear to you. So this was all about your chapter. Now again I am repeating one thing, that now also if you face any problem from anywhere in the chapter, please contact me. So in this chapter we have studied many things. What do you mean by light? What do you mean by what is plane mirror, means characteristics of plane mirror. We have talked about spherical mirror. They are of two types, concave mirror as well as convex mirror. In the concave mirror and convex mirror we have talked about the rule of mirror, and after that we have seen the case of concave mirror and convex mirror. We have seen sign convention of spherical mirror, and after that we have solved some numerical. In the case of lens, we have first talked about the refraction. What do we mean by refraction? And we have seen what do we mean by refractive index. We have seen activity also to trace the path of the light with the help of rectangular glass slab. After that we have talked about the spherical lenses, that is concave lens and convex lens. In the for the concave lens, which is also known as diverging lens, and convex lens, which is also known as converging lens, we have seen the rule and case. After seeing the rule and case, we have talked about the sign convention of spherical lenses. What do we mean by? We have talked about luminous object and non-luminous object. We have talked about the regular reflection and irregular reflection. We have talked about the law of refraction also. In that, Snell's law, N is equal to sin I upon sin R. We have talked, and after that we have seen the numerical on lens. So this was all about the chapter, and from this chapter at least a question of 6 to 7 marks. Basically 7 marks question used to ask from this chapter, a single chapter, light, reflection and refraction. So please make the notes properly. After making the notes, if you have any doubt from this chapter, clear all the doubts, all the things, okay? And don't think that we are at home, that we will waste our time. Don't waste your time. Be serious, because you all know that you are in the 10th class, and the result of 10th is very much important. See, simply passing 10th, it does not matter. But what matter? The matter that how much you have scored. The paper of the board exam are very much easy. For students, those who want to simply pass, but for obtaining good marks, you have to do a lot of practice. And this, especially the physics parts. In the physics part, whether it is a chapter reflection or refraction, after that in our next lecture we will talk about human eye, and we will talk about human eye and colorful world. After that we will study the third chapter, electricity. After that, magnetic effect of electric current. So this all the 4 chapter, electricity, from that 13 marks question used to come in the board exam. And in the case of our this optics, 12 marks question used to come in the board exam. Total from the physics part, 25 marks question used to come in the exam. And 1 chapter in physics also we have to study, that is sources of energy. From that there is a question of near about 3 to 4 marks. So these in the physics part you have to do a lot of practice. If your practice will be good, you can easily score 25 out of 25 in physics. So please don't hesitate. If all the thing is clear to you, it's very much good. But if you are facing any problem, please contact me. That's all about the chapter reflection and refraction. Now here the numerical which I have given to you for practice. Please practice it. And after practicing the numerical, send it to me. And if you have any doubt, please ask to me. Clear your doubt. Thank you.